Today we shall start the first chapter in our 12th standard, matrices and determinants. First topic is inverse of a matrix. Now first exercise we are going to see inverse of a matrix. So inverse of matrices. But before going for this inverse of a matrix, we have to study some other terminologies. Of that, first one is adjoint of a matrix. Once if we know the adjoint, then it will be easy for us to study about inverse of a matrix. Now, adjoint of a matrix. Before that, let me take a matrix. Let A be a non-zero square matrix. So we need a square matrix in which it must be a non-zero. All the elements must be there and all the elements must be of equal row and equal column. Then we say it is a square matrix. Then adjoint of A is given by the formula A cofactor matrix transpose. A cofactor matrix we study in our 11th standard. Cofactor, we have to find out the cofactor matrix of this matrix A, and then we have to find out the transpose of that. If I find the transpose of this cofactor matrix, then it gives the adjoint of A. Remember, we know in a matrix, if it is a 3 cross 3 matrix, then a matrix will have, or the elements will be possessing of these signs, plus minus plus, minus plus minus, plus minus plus. So this we know already. So each element is having this sign in it. That is, each element will be possessing this sign with them. So adjoint, we must be knowing about these things while finding this cofactor of a matrix. I'll straightly go to the exercise problem and I'll tell you how to find out adjoint of a matrix by taking the exercise problem straightly. So exercise 1.1. First problem. Find the adjoint of the following. I'll do the second problem first. A equal to 2, 3, 1, 3, 4, 1, 3, 7, 2. So, remember, adjoint of A, formula is A cofactor matrix, the transpose. So, I have to find out the cofactor for each element. Before that, I have to follow this sign, plus minus plus, minus plus minus, plus minus plus. So, with this one, shall we do? So, if I take the first element, its sign is plus, then the matrix is 2, 3, 1, 3, 4, 1, 3, 7, 2. Omit the row and column of the first element. So, what is remaining? 4, 1, 7, 2. Second element is minus, isn't it? The sign is minus, so minus 2, 3, 1, 3, 4, 1, 3, 7, 2. Omit the row and column of the second element. So what is remaining? 3, 1, 3, 2. Plus. Next element is plus, so plus. Omit the row and column of 1. Now you can easily recognize. It is 3, 4, 3, 7. So I have to find out the determinant, the cofactors for each element. Now next one is minus. Omit the row and column of this 3. 3, 1, 7, 2. Minus plus. For the middle number 4, omit this row and column of this 4, you get 2, 1, 3, 2. Minus. Omit the row and column of 1, 2, 3, 3, 7. Then plus minus plus, minus plus minus, then plus. Omit the row and column of this one, it is 3, 1, 4, 1. Minus. Omit the row and column of this 7 now. This one, then you have 2, 1, 3, 1. 2, 1, 3, 1. Plus. Omit the row and column of 2, it is 2, 3, 3, 4. Correct? 2, 3, 3, 4. Don't forget to put this transpose. Now we shall simplify this. Each one is a 2 by 2 matrix now. So it is. So we put the sign also. 8 minus 7 minus 6 minus 3. I have to multiply these two. Then while multiplying the other two, I must change the sign. Plus 3 sevens are 21. So it is 12. But I must put minus 12. Minus 3 twos are 6 minus 7. Plus 4 minus 3. Minus 14 minus 9. Now it is plus 3 minus 4 minus 2 minus 3 plus 12 minus 9. Whole matrix, the transpose. Therefore, adjoint of A equal to 8 minus 7 is 1. 8 minus 7 is 1. Then it is 6 minus 3 minus 3 because of the minus sign. 21 minus 12 is plus 3. Minus 12 is 9, sorry. 6 minus 7 minus 1, so plus 1. 4 minus 3 is 1. 14 minus 9, 5, so minus 5. 3 minus 4 minus 1. 2 minus 3 minus 1, so plus 1. 12 minus 9, 3. So plus 3. The transpose. So adjoint of A equal to, when you transpose, you will get 1, 1 minus 1. First, all the rows will become column, all the columns will become rows. Minus 3, 1, 1. 9 minus 5, 3. 1, 1 minus 1, minus 3, 1, 9 minus 5, it is 3. 12 minus 9, sorry, it is 8 minus 9. 8 minus 9 is minus 1, so this will become minus 1. 9 minus 5, minus 1. This is called adjoint. This will become still simpler when you do more problems. So this is about the first problem. So that's the second one under the first. Under the first problem, we got the second subdivision. Now we should go for third one also. After that, I will come to the first problem. Now, third one, A equal to 1 by 3, 2, 2, 1, minus 2, 1, 2, 1 minus 2, 2. There is no additional number in front of this matrix. That means instead of the form from lambda into A matrix, I have to find out adjoint of lambda into A matrix. Then we have a theorem. The theorems we shall see afterwards. Just note down the theorem. Adjoint of lambda A equal to lambda power n minus 1 into adjoint of A. This is the theorem where n is order of the matrix. Where n is the order of the matrix. So this is the theorem. Whenever if a matrix is multiplied by a constant. So adjoint of lambda A means lambda power n minus 1 into adjoint of A, where n is the order of the matrix. So then the order is 3 cross 3. Therefore adjoint of A can be written as 1 by 3 whole power 3 minus 1 into adjoint of this matrix, or just we shall write A cofactor transpose. So this is, since the 3 means order is 3 cross 3, therefore it is 1 by 9 into, can you tell me the cofactor of this one? Plus, moment this row and column, you will get 1 2 minus 2 2 minus, moment the row and column of this 2 minus 2 2 1 minus 2. Omit this row and 1 2 minus 2 1. Then plus. Omit the row and column of the first term. Then it is minus 2 1 1 minus 2. So we shall close this. Don't forget to put this transpose. For the second row, it is minus. Omit the row and column. Then it is 2 1 minus 2 2. Then the common elements always 2 2, 1, 1, 2. Then plus, minus, it is minor. Omit the row and column of 2, 2, 2, 1, minus 2. For the third row, it is plus. Omit this row and column, you will get 2, 1, 1, 2. Minus. The next one, it is 2, 1, minus 2, 2. Then for third one, it is 2, 2, minus 2, 1. That's all. We have to simplify this. So adjoint of A equal to 1 by 9 into, simplifying this, plus 2 plus 4. I have to, while multiplying these two, we must change the sign. Minus 4 minus 2 plus 4 minus 1. Then it is minus 4 plus 2. 4 minus 1. Minus 4 minus 2. 4 minus 1 minus 4 plus 2. 2 plus 4. The transpose. That is 1 by 9 into, it is plus 6. 4 minus 2. Check this error pattern. This one minus 2, 2, 1, 2 only. So it is minus 4 minus 2. So minus 6 it will be plus 6. 4 minus 1 is 3. Minus 6, 3 minus 6, so plus 6. 3 minus 6, 6. The transpose. Now you transpose first. Then you get 6, 6, 3 here. Minus 6, 3, 6 here. 3 minus 6, 6. Now, can you see, a number 3 is common. So, if I take 3 out, then this will become 2 minus 1, 1. Because in a matrix, I can take a number. So, it is 2, 1 minus 2. 1, 2, 2. So, the answer is 1 by 3 into 9 and 3 cancels. So, 1 by 3 into 2 minus 1, 1. 2, 1 minus 2, 1, 2, 2. Here if I take 3, this will become 2. So it is minus 2. So this is the adjoint of A. So if you have a constant multiplier with the matrix, then you must apply this theorem. And this is the only problem you have this form. So it is lambda power n minus 1, where n is the order of the matrix. And if you find the adjoint, it will be easier. So this is the method we are following. And it will be easy also. Suppose if it is a 2 cross 2 matrix, how to find the order for the adjoint? That is our first problem. We are not going to study anything. So in one step we can write the adjoint. So that I give this one at the end. Minus 3, 4, 6, 2. So the easiest method is adjoint of A equal to, no need to find any cofactor matrix, no need to transpose anything, just this is the main diagonal, isn't it? Just interchange these numbers, this will become 2 minus 3. Now, don't change these numbers, but change their sign only, that is plus 4 will become minus 4, plus 6 will become minus 6. That's all. This is the adjoint, straightly. 2 minus 4 minus 6, 3. So, are you able to follow? Just interchange the numbers in the main diagonal. And change only their sign, that is plus into minus or minus to plus, to the additional diagonal. That's all. You will get the adjoint straightly, no transpose, nothing. This is called adjoint of A if it is a 2 cross 2 matrix. So with this idea, hope you have understood what is meant by adjoint. But in all the problems we are going to do adjoint once again. So even if you are not able to understand now, you will be understanding while doing inverse of a matrix. So next we shall go for next topic, inverse of a matrix. Let A be a non-zero square matrix. Then inverse of A is written as A inverse. Remember, A inverse means it is not equal to 1 by A, because we cannot divide a matrix. So A inverse means notation. A inverse is given by the formula 1 by determinant of A into adjoint of A. 1 by determinant of A into adjoint of A. So, inverse exists only if the determinant is existing. That is, if the determinant is becoming 0, inverse does not exist. So, take that one as a node. A inverse exists only if determinant of A is not equal to 0. So this condition. So first of all, whenever you are asked to find out the determinant of a matrix, you must asked to find out the inverse of a matrix. You must find the determinant of A and ensure that one is not equal to 0. Then only you can proceed for finding inverse of the matrix. Otherwise, the inverse won't exist. So I will go for the exercise problem straightly, and you can do all the problems if we know this one, because we know what is meant by adjoint now and we know how to find determinant. So using this we shall find the inverse also. While doing these problems also, I will give you some shortcuts to find out the adjoint of matrix. So again we shall go for exercise 1.1, second problem. Find the inverse of the following. Again, I will go for 3 by 3 matrix straightly. A equal to 5 1 1 1 5 1 1 1 5. So I have to find out the inverse. So inverse formula is A inverse equal to 1 by determinant of A into adjoint of A. So we shall keep this one as 1. So first we shall find determinant of A and we shall ensure whether it is becoming 0 or not. So determinant of A. Remember, take this 5, omit the row and column, it is 5 1 1 5. So also it is plus 5. Then minus 1, isn't it? Omit the row and column, it is 1 1 1 5. 1 5 1 1 1 5. Then plus 1, omit the row and column, first one it is 1 5 1 1. We studied in our last itself. So how to find determinant? So 5 into 25 minus 1 minus 1 into 5 minus 1 plus 1 into 1 minus 5. 5 into 24 minus 1 into 4 1 into minus 4. 5 24s are 120 minus 4 minus 4. 120 minus 8 is 112, which is not equal to 0. Therefore, A inverse exists. So now we can find out adjoint of A. Now, let me try to find out this adjoint of A in a shortcut way. For that only, I found this determinant of A. That is, I expanded determinant of A along row 1 because of to find this adjoint of A easier. Listen here. Adjoint of A equal, remember, A cofactor matrix transpose. We shall find the cofactor. Plus, suppose if I omit this 5, I get 5 1 1 5, isn't it? Is it not here? So, it's better you can just copy the determinants here for the first row. That is 5 1 1 5 minus 1 1 1 5 plus 1 5 1 1. Remember the transpose. Just find out the cofactor for the second row alone. Minus. That is 1 1 1 5. When I omit this 1 1 1 1 5. Plus always the corner elements 5 1 1 5 minus. For this one, omit this row and column 5 1 1 1. Now the third column, so are you able to follow? First row I copied from here. Second row only I found. For the third row, listen here, write this one first, that is 1 1, then 5 1. Check it, is it correct? 1 1 5 1. Just write this one first, then second this one. First this, second this. Minus, see, 5 1 1 1. Correct? Plus, first this, 5 1, Second one is 1 5. Check it. 5 1 1 5. That's all. If I simplify, that gives me the adjoint. So it is plus 25 minus 1 minus 5 minus 1 plus 1 minus 5 minus 5 minus 1, 25 minus 1 minus 5 minus 1 plus 1 minus 5, 5 minus 1, 25 minus 1, the transpose. Therefore, adjoint of A equal to plus 24. It is 4, so minus 4, minus 4. 4, so minus 4, plus 24. 4, so minus 4, because of this minus sign. It is minus 4, 24, the transpose. Therefore, when I transpose this, all the columns will become row. 24, minus 4, minus 4, minus 4, 24, minus 4, minus 4, minus 4, 24. Can I take 4 as a common term? Then this becomes 4. This is adjoint of A. 4 into 6 minus 1 minus 1. Minus 1, 6 minus 1. Minus 1, minus 1, 6. Therefore, shall we apply now in, so adjoint of matrix is ready. Therefore, A inverse equal to 1 by determinant of A is 112 we found into 4 into 6 minus 1 minus 1 minus 1 6 minus 1 minus 1 minus 1 6. 4 and 112 can be cancelled. It is 1 by 2 times 8 remainder 332 8 times 1 by 28 into 6 minus 1 minus 1 minus 1 6 minus 1 minus 1 minus 1 6. This is your inverse of the matrix. So inverse exists only if this determinant is not equal to 0. Otherwise it will become infinity. So this is second problem under 2. Now I will do one more problem also under 2. Under 2, second problem. Find A inverse. If A equal to 2 3 1 3 4 1 3 7 2. So first write the formula, then find the determinant, then go for adjoint. That must be the procedure. So A inverse is 1 by determinant of A into adjoint of A. Keep this one as 1. Make sure by finding this determinant whether it is becoming 0 or not. Determinant of A means expand always along row 1 because that will be useful to find the adjoint. So it is, you write the expansion 2 into, commit the 2 on column 4 1 7 2. Second element sign must be changed, so minus 3 into 3 1 3 2 plus 1 into, omit the 2 on column 3 4 3 7. Check it 4 1 7 2. Then I omit 3 3 1 3 2. Then I omit this 1 3 4 3 7. It is 2 into 8 minus 7 minus 3 into 6 minus 3 plus 1 into 21 minus 12. 2 into 1 minus 3 into 3 plus 1 into 21 minus 12 is 9. So 2 minus 9 plus 9, it is 2 not equal to 0. Therefore, A inverse exists. Now we shall go for adjoint of A. So if I go by the chart method, it will be still easiest. That is, adjoint of A is given by the formula A cofactor transpose. Therefore, adjoint of A equal to, find the cofactor matrix. It is plus, this one first, 4 1 7 2 minus 3 1 3 2 plus 3 4 3 7. Next minus. Now go for the matrix. Minus. Omit this row and column of this 3 3 1 7 2 plus Always the common elements. 2, 1, 3, 2. Minus 2, 3, 3, 7. This one 2, 3, 3, 7. Next. I told you can write from here itself. Plus 3, 1 first, 4, 1 next. Minus 2, 1, 3, 1. Plus 2, 3, 3, 4. Third determinant. So it is plus 8 minus 7 minus 6 minus 3 plus 21 minus 20. The transpose minus 6 minus 7 plus 4 minus 3 minus 14 minus 9 plus 3 minus 4 minus 2 minus 3 8 minus 9. Therefore, adjoint of A equal to 1. It is 3, so minus 3. 12 minus 21 minus 12, 9 plus 9. It is minus 1 but plus 1. So 4 minus 3 plus 1. 14 minus 9, 5, so minus 5. 3 minus 4 minus 1, 2 minus 3 minus 1, so plus 1, it is minus 1 transpose. So now transpose it. It is 1, 1 minus 1, minus 3, 1, 1, 9 minus 5, minus 1. Therefore, 1 implies A inverse equal to 1 by determinant of A is 2 into adjoint of A 1, 1 minus 1, minus 3, 1, 1, 9 minus 5, minus 1. So this is how we can find the inverse of the matrix. So now it is familiar for us after seeing these 4 problems. Now let me go for first problem because it is a 2 by 2 matrix. If A equal to minus 2, 4, 1 minus 3, find A inverse. Since it is 2 by 2 matrix, straightly we can go. That is A inverse equal to 1 by determinant of A into adjoint of A. That is 1 by determinant of A means multiply these two, it is plus 6 minus 4 into adjoint. Remember, I have to interchange these two numbers, minus 3 minus 2. Change the sign for these two numbers, plus 4 will become minus 4, plus 1 will become minus 1. It is 1 by 2 into minus 3 minus 4 minus 1 minus 2, or I can write as minus 1 by 2 into 3, 4, 1, 2. Minus sign if it is taken. So it is 1 by 2 into minus 3 minus 4 minus 1 minus 2. So this is how. So if it is a 2 by 2 matrix, it is very simple for finding adjoint. Just interchange these two numbers and change the sign for the other adjoint. Determinant we know it is 6 minus 4. So with that, now hope you will be understanding what is meant by inverse of a matrix. 1 by determinant of A into adjoint of A.